So that's the deal. We're going to be going to get lunch pretty soon, so we don't have a ton of time. When I was last here, so 2 days ago, true or false, didn't I assign some homework to you guys? Not at all? I know we talked about word problems a little bit. I don't think we assigned homework. I just wanted to make sure. So let's talk about some word problems real quick. Let's talk about some word problems. It's frickin' bats. It's frickin' bats. All right. Oh, I did. I believe I did assign homework. I did assign this.
What is that?
Oh, you've seen it. I definitely assigned it. Are you kidding? I waited this entire time, and now?
Is it Parker?
No, it's somebody else. Oh no.
What?
7,
face.
8, 6, 7, 5, 3, 0, 9, 8, 6, 7, 5, 3, 0, 9, 10, 9, 8, 7. 2, 4, 6, 8. Yeah, go away. All right. Here it is. Yep. Mm-hmm. How is 1 through 4?
I did 2.
Calm down. So cranky today.
I did 2 and 5 and 6.
How do you feel about 5 and 6?
We did them in class.
I know we did it in class, but do you understand them?
Yes.
No.
Like, I forgot how to do it.
All right, I'll do one example right now just to walk you through it. It's all good. Remember, homework is for understanding. That's the whole purpose, right? All right, Caden, put it away.
7?
Didn't we already do this?
We did.
We did 5, 6, and 2.
Help me. All right, so number 5. Or would you rather see number 6? Which one would you rather see?
7.
5.
I'm asking 5 or 6 because you said you didn't understand them.
Oh, I had them 2 down. I just forgot how to.
But you're good? You feel like you got it?
Sure.
Okay.
Wait.
Does anybody need to see number 6? Yes. Okay. Let's see number 6. So 3 consecutive integers. Now we learned earlier in the year there's a way to write that algebraically, right? Starting with your first number. And then our second number will just be whatever n plus 1 is, right? Sorry, that looks like a T. What? Why would I do that? Okay, let's try it again. N plus 1. There we go. Okay, so we have 3 consecutive integers there. There's integer number 1, there's integer number 2, there's integer number 3. Yes, sir.
It says 3 consecutive even.
Bump, bump, bump. So now how do we make it even?
3 and 3.
Thanks for spoiling my trick. Yes, what do I do?
Instead of adding 1, you just add 2 to the 4.
You can still show it.
How did you get 4?
This has to be.
Does it work? Give me a number for n. Baker, give me a number.
I go to the bathroom.
Nope, give me a number.
Well, can I give you a number?
Yes, give me a number.
Between 1 and 10,
I need you to give me an integer. And second of all, like, you had all this time to use the bathroom, dude. Use it before.
I'm sorry.
It's cool. I understand. I don't care. But, like, now you're going to miss class time, and that sucks for you, man.
Well, I can just have my phone set up and videotape.
I suppose so. You can watch this later. You can watch it in the bathroom, right? So anyway, give me a number for n. I need an integer.
Never mind.
4.
4. All right. So if I have 4 here, that gets me 4. N plus 2 then gets me 6, and then 4 is n, so I get 8. Does that get us 3 consecutive even integers?
Yes.
Okay, so it checks out, right? So that's the formula. So we have this now. That 1/2 of their sum is between 15 and 21. So a half of their sum, well, there's their sum, right?
3n plus 6.
So half of it's going to be this, divided by 2. And it's going to be between 15 and 21. So it's between, literally between. 15 is the smaller number. 21 is here.
I used the bathroom yet?
Yeah, go.
I was just waiting to.
Let's go. So now we're here. Let me get some paper out, and we'll write this out officially, and then we'll mess with it. Okay, because they want it simplified. And by simplified, meaning that there isn't a lot of crap going on in the middle. All right, so we have n plus 2 plus n plus 4. And that's all over 2. And it's between 15 and 21. Cool? Oh, yeah, I'm sorry. I'm zoomed in. My bad. How about that? Thanks for telling me. Frickin' bats. It's frickin' bats. I love Halloween. All right. So, how do we get all that stuff down to like one thing?
We got all the ends together.
What's your strategy? What are you going to do first? Yeah.
I'll add all the ends together.
Okay, so you're saying I'm going to get all the stuff together first that's already there. Ethan, you were going to say multiply by 2. Either way is valid. Let's get the ends together. How many ends do I have here total? 3n. You sound like a barrel of sunshine today. 2 and 4 added together. What's that? 6. All over 2. Less than 21. All right, and then Ethan said we're going to multiply by 2, right? That's going to get rid of this. Now, when we multiply or divide or do any property of inequality, it says we have to do it to all the sides. So everything is going to get multiplied by 2. The 15 is going to become a 30. Wow, that was fast. And then 3n plus 6. I appreciate the effort. 42. Why mess around? Fire hose, yep. Reminds me of a very funny clip, which we will not watch in class. All right, so now we're here. I know, right? So now we're here. Now what do you want to do? Subtract the 6. We have to do it to all the sides. Do I need to flip the signs? Nope, because I'm not dividing by a negative. I'm just subtracting. Cool?
Yeah.
Now what? Somebody other than you. Shion.
Who's you?
Divide by 3.
24 divided by 3?
8.
Oh, shit. Because 21 is 7, right? 36 divided by 3. Well, 10 is 30, right? So 11 is 33. 12 is 36.
12.
Very good. Cool. If you don't know off the top of your head, think about what you do know. I know 3 times 10 is 30, so 3 times 11 is 33. 3 times 12 must be 36. Now I'm here. So when I say the sum of 3 consecutive integers, half of their sum is between 15 and 21, what I'm really saying is I'm thinking of a number that's between 8 and 12. That's my starting number for the integers, right? Any number that I start on between 8 and 12, half of the sum of the 3 consecutive even integers will be between 15 and 21. Let's check that. So, Baker, give me a number, an integer, that is between 8 and 12. 10. Okay. So there's 10. What's the next consecutive even integer? 12. And the next one?
14.
Okay, cool. Now, it says the sum of these, cut in half, should be between 15 and 21, right? Let's check it. So we add them all up. 10 plus 12 plus 14. We've got 10 and 14, which makes 24. 24 plus 12 is 36. Okay, so 36. We divide that by 2, we get 18. Is 18 indeed between 15 and 21?
Yes.
Yes, it is. What's your question?
Oh, never mind.
Cool. All right, so that checks out. That checks out. The upper limit on this is 12, right? So what do you think would happen if I actually chose 12 as my starting number? What would happen? I get 12, 14, and 16. If I add them up and divide by 2, I'd get exactly 21, which is just outside our range, right? Same thing if I chose the bottom part of this, right? If I chose 8, then I'd end up with 15, I bet. Right? Which is just outside our range because it's not less than or equal to, right? It's just regular less than. So this one, 8 less than n less than 12. I like problems like this, right? 3 consecutive even integers makes you think. How do I write that algebraically? What does the algebra mean? When we just talk about a number between stuff, you don't have to think about stuff. I just write x because that's what you do in algebra class, right? 7. Want to see it?
Of course.
Okay. I heard a yes. An emphatic yes.
Of course.
Of course. All right, so we subtract 6 from both sides. It's probably a good first move. Could you divide everything by 6 first? Yes, there is no law against it. You just have to divide every single thing. How about we do that? Because in this case, I can divide everything by 6, can't I?
Yeah.
It'll end up being nice, so who cares? Let's divide by 6 first. The 6 becomes a 1. The 6 becomes a 1, so just 1a. The 6 becomes a 1. And the negative 30 becomes a negative 5.
Negative 30.
Yes. He just like broke for a second there, Jace. All right, so now we're here. And why is this okay? Because I divided every single thing by 6, and it's all good. You could do that even if it didn't work out nicely. You just have fractions. It's okay. Now I subtract 1, I get 0 here, and that's okay. Was that what was scaring you, the 0? And then I get this. I subtract this, and I get -6. Ta-da! Did I divide by a negative?
I got the same answer, but I did it pretty good.
Yeah, you probably subtracted 6 first, right? You can do it in any order. Remember, PEMDAS is a lie. As long as you obey the rules. Subtraction says you do it to every side. Division says you do it to everything, right? So I had to do it to every single thing. You be all right? I'm sorry. Yeah, it's awful in here. I don't know how to fix it. 8 can be on your own.
Wait, is that all you need?
That's it. Well, actually, I mean, we need the solution set. So I should say this is what we want. Whoops, my bad. That's a line. Here's A. There we go. Also, set notation done like this. It's inclusive, right? So it's between 0 and 6. That's the range. Right? And then we got to graph it. So here is 0. Here's 6. 6 is bigger, so it goes on the right. A is in between. -6. Ah, bummer. Bummer. Here's -6. Here's 0. Open or closed?
Open.
Definitely closed.
I wasn't even looking.
Less than or equal to.
Open.
Yeah, relax, guys. It's closed. -6 and 0.
Open if it's.
It's closed.
See how there's a line underneath?
Yeah, I thought it was open if it was like.
Nope, it includes. Remember, what we color in is what it includes, right? That's why when I scribble in here, that means that's where A is, right? So Baker, it's any number between 0 and -6, but it also includes 0 and -6 because it's less than or equal to, right? So it includes those, which is why I color in those circles as well, because it can be there, right? Where we're colored in is where we are. Good question. All right, moving on. Let's take a look at 13, 14, 15. Particularly 14. 13, I should say.
13, 14, and 16.
The sum of 4 times a number and 8 is between 0 and 12. Woo! That's some words. The sum of 4 times a number. So we're going to be adding 2 things together. That's what the sum means, right? So what's 4 times a number? How do I write that?
4x.
4n, or x, or a, or whatever you want, right? 4 times a number and 8. What are we doing with 4 times a number and 8? We're adding, we're summing them, right? Is between. Okay, now we have a relation. Is a relationship type of word. Usually it means equal, right? But in this case, we're talking about a range. So is between 0 and 12. Which one's smaller, 0 or 12?
2.
All right, so I'm going to write 0 on the left and 12 on the right, and that means I've got this. Is between those two. Yes. Does that make sense?
No.
That's not so bad, right?
No.
The sum of 4 times a number and 8. That's the sum of 4 times a number and 8, between 0 and 12. Find the range of numbers. So we need simple n on the inside. So I'll subtract 8, or do you want to divide by 4? What do you want to do? We'll subtract 8. We get -8 here. Do I need to flip the sign? No. And I get 3 there. Now I divide by 4. And I get this. It's between -2 and 3/4. Oh, you got me. 4 divided by 4 is 1. So it's between -2 and 1. If I've multiplied the number I'm thinking of in my head and add 8, and I tell you that it's in between between 0 and 12, the result is, right? There's only a couple options. The number I started with could have been -2, it could have been -1, it could have been 0, it could have been 1. That's it. And if I choose -2 and 1, it'll actually be exactly 0 or 12. So really there's only 2 options if we want it to be less than or equal to, -1 and 0. Right? That's what that's saying. So this is our range for n. Right? It's between there and there. Another way to write that is not inclusive, so -2, 1. Right? We have the regular brackets, parentheses. And when we graph that, we would say that n is in between -2 and +1. And those are open circles because it doesn't include 1 and -2, right? We have less than signs, so it's open circles. And n is between them, so n is here.
Ah.
A store is offering a $30 mail-in rebate on all color printers. Now, I hate when they do stuff like this because, first of all, the only printers you ever know are color printers. And also, $30 mail-in rebate, what does that even mean? Yes?
You mail it, or you write it? For the other question. I don't know, good job. That's, how do you get, what?
This right here, this is what you're confused about?
I'm confused about the one. I don't know if I did.
12 divided by 4 is, I'm sorry, 4 divided by 4 is 1.
Wait.
I wrote a 3 at one point, and you might have been copying it down without thinking, which is never a good idea. So I had a 3 there originally. I goofed on that. It's supposed to be a 4 because 12 minus 8 is 4.
Oh.
Yes. Yes.
Why does the -2 want in the and not like the box?
So on the other page, we did the box, the square brackets, because it includes 0 and includes 6. It's inclusive. Okay? These guys mean it's non-inclusive. That's all. It's confusing because it also looks like a coordinate. Sorry. I just want you to know what it looks like because it is confusing. That way when you do, you don't get, right?
That's an open circle, right?
Open, open. Yep. $30 mail-in rebate on all color printers. Luis is looking at different colored printers that range in price from $175 to $260. How much can he expect to spend after the rebate? Well, how much he's spending? What do you want? What variable do you want to use for that?
S for spending.
S for spending, which looks like 5s, but we'll do it. Okay. So how much he is spending in total? How does that relate to the $30 mail-in rebate? Do you know what rebate means? It means you get $30 back. Not when you pay for it, but what you do is you take the little coupon and you send it in the mail, and then they send you $30. And the reason they do that is because it looks like the price is cheaper, but no one actually ever remembers to do the rebate, right? So it's like a sale that you don't actually have to get people money off for. Very rarely do they remember to do it. So S is how much he's spending. However much he spends in the store, he's going to get $30 back, right? So the total amount that he's spending is actually going to be 30 less. You see what I'm saying? You see why we subtract the 30? Now he wants to spend in total after the rebate between 175 and 260. So 175 is smaller. So I'm put that on the left. 260 is bigger, so I put it on the right. And there we go. Now this is how much he's going to spend factoring in the rebate. If we add 30 to both sides, make those numbers bigger. What does that mean? Let's move the 30 over. We get 205. 290. So that is saying he's going to spend between $205 and $290. What do you think about that?
It only can be certain amount.
So it's saying the amount that he's going to spend is between 205 and 290.
Wait.
I thought the price range was 175 to 260. How come he's paying more now? Yeah.
You had to add the 30 and not subtract it.
Why are we going to add the 30? What does this stand for? This thing right here. What does that mean?
He gets $30. It's $30 Wait, he loses $30 and then he gains it back? That means it-
Yeah, Nevea, that makes sense to me. I would say, well, he's going to spend the 30, and then he's going to get it back. So that's plus 30 minus 30. And what happens when we do plus 30 minus 30? It's 0. So he's going to spend between 175 and 260.
That's right.
Now, how much is he going to spend after the rebate, though? He's going to spend less. So, Nevea, what you were saying makes a lot of sense. But we want to know how much he's going to spend after the rebate. So what we need here in the middle is how much he's going to spend after the rebate. Well, it's going to be S minus 30, right? How much he spent before minus 30? How do we write this and have it make sense? Did it make sense before?
Wait, why did I get crossed out?
Nevea was saying that if we have a minus 30 here and we move the 30s over, it makes the amount he's spending more. Which, shouldn't he be spending less after the rebate?
Yeah.
So here's the thing. This is already what he's spending after the rebate, right here. That's what this is. How much spent after rebate. Right? It'll be $30 less than what he spent originally, which is S, right? So this is done. We don't need to solve for S. That's how much he's spending after the rebate, right? Now question. If you're buying a printer and you want to have between 175 and 260 spent total, if you only have that much money, you can't go in there and be like, oh, well, I can actually spend 290 because I get a $30 rebate, because you'd have to spend 290 up front, right? So we're going to assume that Luis has deep pockets and that he's cool with spending up to 290 and between 205 and 290, and then get the money back later. Now, you have to have money to spend to be able to be like, it's okay if I get the money back later, right? Right? So that's the catch. Gross. 15, the perimeter of a triangle is between 10 and 15 inclusively. So we're going to deal with less than or equal to signs? Inclusively. What kind of signs are we going to use? Less than or equal to, right? If two sides of the triangle are 3.7 and 5.2, find the range of possible measurements of the third side. So the perimeter is between 10 and 15. And we know two of the sides are 3.5 and 5.2. How many sides does this triangle have? 3. So we have 3.7 plus 5.2 plus S, the other side. What's the perimeter between? That's our perimeter, right? All of this stands for the perimeter. Perimeter is all the sides added up. I don't know one of the sides, so I wrote S. Now, what's the range for our perimeter? It's between what and what? 10 and 15. Find the range for the possible measurements of the third side. So we need to get S on its own, right? Right now, it's all perimeter is what that stands for, right? If we remove those two, then we're just talking about the one side, which is what they want to know about. How do you feel about setting those up? Not too bad? Right? It's different. It's weird. Words are hard. Math is easy. But I hope you'll start to get the hang of it. That's the idea. If you haven't finished this up, finish it up for Monday, or turn it in now. It's up to you. Yeah.
So the miniature are getting self-help points then?
Not yet.
Like you have Lindsay self-help points then?
What?
Like you have Lindsay self-help points then?
Because she got it 100% right.
Are you trying to do a phone score?
No. Well, you didn't. Hold on. She got points not because she knew the reasoning, but she found a unique square, right? And if you guys can find a unique square, I'll give you half the points. But you haven't told me it's unique. Like, I would have to look and check. Like, you can look and check and see if it's unique. I think it's back there on the wall somewhere. Yeah, it is. Yeah. So check that box.
I'll just check it.
Yeah, on Monday. I don't care. You have until the end of the semester. All right. See you later.
Whoa! Sorry to break check everyone that was behind me.
Yeah, you did. Feeling okay?
Yeah.
Yeah? All right, good. Have a good weekend.